Anyone want to do number 1 on the board? The one right next to the color still looks like the lines get that. Okay, so I'll explain. So from substitution or method of substitution, you have to get one of the variables by itself. Which one you chose is up to you. But this one would have been the easiest. Get rid of the 3x by subtracting. Take this portion of the equation, put it in for the other y, and then start to solve. So distribute, combine like terms, get rid of everything else so you have x by itself, and then divide. These are both 17s, negative 17. So x was 1, and then put that 1 back in one of your equations and find y. So we should have gotten 1, 2 as our solution. Who else got that? Good, good. Any questions on number 1? Anyone want to do number 2? Alex, go for it.
Am I allowed to do this again?
Sure.
It's hard to
Yeah.
actually line. So, you draw your points first, and then do this with the arrows.
It might just be on there. I don't know what that is.
Do all your points first. Okay, so think a line was made. I think that's what that is. That little part, I think a line was made. I think that's what that is.
So for this one, you had to graph both. One is already in slope intercept form, graph all your points. The other one, you could either graph as is or switch them and graph that. And you should have gotten this one. Who else got that point? Then we'll go over the last one when we get back. Last one. You want to do number 3. So this is from what we were doing last class. Eliminating. And there are multiple different ways you could have done this. So it doesn't have to match mine exactly. If you were going to eliminate the x's, you could either multiply the top equation by 3 and the bottom by 2, multiply the top by 6 and the bottom by 4 to get rid of x, or keep going by multiples of x. For y, you could have multiplied the top by 7 and the bottom by 5, or keep going. So I'm going to do this one, multiply this by 3 and this by 2. So we get 12x plus 15y equals 18, and 12x minus 14y equals negative 40. Anyone else start this way? And again, that's fine. Don't erase. If you did something different, you will get the same answer as long as you did your math right. Would we add or subtract to eliminate the x's? So then these will cancel. 15 minus a negative 14 would be a positive 29y. 18 minus a negative 40 would be a positive 58. Divide both sides by 2. Then take that y value, put it into either any of the equations you have, and find your x. So if I choose this first one, 4x plus 5 and 2 equals 6. And then solve for x. No matter how you solved it, by elimination, whatever you multiply by, as long as you got negative 1, 2, you're good. You all got that answer. Good. Anyone want to do number 4? So number 4 was something we talked about at the beginning, where we have to double check both of these by putting this into both of them to see does it work or does it not. So we would put it into the first one and get 6 plus 1, which does equal 7. And then do the second one and see if we get the same thing. So multiply the 6 and the negative 1/3. This one is not true, so this is not a solution. We say it's not a solution because it is only true for one of them, or it only makes one of these true, not both. Questions on that one? Get out a sheet of scrap paper, either in a notebook, loose leaf, you can grab one of mine, and a highlighter or color pencil or pen. I have highlighters, but they're only one color. If you want multiple, colored pencils are in the pencil boxes. You'll need that for the notes we're going to start today. Alright, so today we're going to talk about the last set of notes lesson in this unit, word problems, which I know is our favorite thing. I'm being sarcastic. So we're going to read through this and find the important things, highlight, circle, underline, all of those. So read with me. A snack bar sells large and small nachos. Large nachos cost $5 and small packs of nachos cost $3. In one day, the snack bar sold 60 packs of nachos for a total of $220. Let L be the number of large nachos and S be the number of small nachos. Write a system of equations to model the situation and determine how many large and small packs of nachos were sold. What do we think is important from this? Okay. Anything else we find important? So those are both important, the two totals. Anything else? Hannah? And what are we looking for? Major. So we have a bunch of important information going on, and we already have variables that are defined, but we're going to get in the habit of defining variables, setting up our equations, and then solving. So, even though they already defined our variables, sometimes you won't have that, so defining them first will help you. If they didn't already define them, we would look at the question to help us define them. but they tell us that L is the number of large nachos, and S is the number of small nachos. Then we have two totals, the 60 and the 220. We know we're going to have two equations, so we can set one equal to 60 and one equal to 220. Okay. Money always goes with money. So the 5 and the 3 are going to go with the 220. How would we write that into an equation using our variables and those numbers? Have each pack of large nachos costs $5, each pack of small nachos costs $3. We know L represents the number of large nachos, we know S represents the number of small nachos, and it's going to equal 220. How do we put that together? Nature. Or backwards, either or, does not matter. So then 60, we know, is the total number of packs sold altogether. What else represents number of packs or number of nacho packs? Major? L and S, so if we add them together, we should get that. So, Hannah, are you okay? Okay. After you define your variables and you set up your equations, the methods of solving are the ones we already know, so you don't have to learn new ways to solve, either by substitution, by elimination, or by graphing. So we're going to rotate through those. We're going to do this one by graphing, and we're going to do that in our calculator. But in order to do that, we need X and Y variables instead of S and L. So we're going to change these. Does not matter which one you change to whatever. Just be consistent. So if you change one S to be X, the other S has to be X, and vice versa. So I'm going to rewrite those. Then we'll need to solve both equations. So solve them both for y. Get y by itself. So this one would give us y equals negative x plus 60. And then we have to divide everything by 5. This as a decimal, you can do that. So these are our two equations. You're going to put those into your calculator in y equals. So negative x plus 60 and negative 3/5 Then we would graph those. I didn't have you guys reset your calculator, so you may be able to see it right now. You may not. If you can't see it, we'll have to zoom to something to find it. So I always use Zoom Fit. So in Zoom, go to Zoom Fit 0. And you should be able to see the lines, but we have to see where they cross. So we have to zoom out a little bit more. So zoom out 3, and then hit enter. That might work even if I close it. From where? From where? Then from here, find where they intersect, second trace, and then intersect, and then hit enter 3 times. And then we would write down that point, and then do more with it. So then we know x was L, I'm sorry, x was S, and y was L. So we would rewrite those with labels. So we have 40 small packs of nachos. And 20 large packs. So in every question, you'll have to define your variables, set up your equations, solve it using one of the methods, find your 2 answers. Well, some of them you'll only need to find 1, and then make sure you're labeling them. Questions on that? We're going to skip example 2 and go on to example 3. Matthew, what do you left off? We're not doing diagrams right now. So read this along with me, either on the board or on your paper. Christina went to the mall and bought 5 pairs of earrings and 2 pairs of shoes for $30. Each pair of shoes costs $2 more than 4 times the cost of earrings. Let E be the cost of earrings and S be the cost of a pair of shoes. Write a system of equations to model this situation and determine the cost for a pair of shoes and a pair of earrings. What is important there? $30 is going to be a total. Anything else we find important? Lily? Yeah, that entire sentence is important. Anything else? Nature? And what are we looking for? Define your variables, even though they're already defined, go ahead and write what they said down. So E and S are the cost of both of these things. And the cost of the variables. Anytime we define our variable, we need to be specific. Cost of, number of, those type of things. And of what? We know 30 is going to be one of our goals. And even though I said money goes together in the last example, because the 5 pairs of earrings and 2 pairs of shoes total up to 30, those are all going to go together. That sentence. So how could we set up that 5 pairs of earrings and 2 pairs of shoes for $30? What do you think? How could we put those together in the equation? You have your variables, you have your numbers, you have your total. We can't come up with an equation, we can't continue. Nature. The trickier part is coming up with the equation for the second one. Because of how it's written. So each pair of shoes costs $2 more than 4 times the cost of earrings. So if we knew the cost of earrings and we multiplied that by 4 and added 2 to it, we would get the cost of a pair of shoes. So this is going to be a S equals. How would I write the rest of that? Matthew? I'm going to rearrange that a little bit. 4E plus 2 or 2 plus 4E of either or. Of your methods of solving systems, which one would work best for this? Nature? Substitution, because we have a variable already by itself. So we're going to take 4E plus 2 and put it in for S. And then solve for E. Combine your like terms. Get rid of 4. And divide. So the cost of the earrings is what? So you would either say E equals $2 or you would write it out in a sentence. Earrings cost $2. Take that value, put it back in, find S.
square what?
Questions on this?
On to the next example.
So for this one, you have $3.70 in dimes and quarters. You have 5 more quarters than dimes. Let D be the number of dimes and Q be the number of quarters. Write a system of equations to model the situation and determine how many dimes and quarters you have. What is important here? So the 370 is actually going to be a total, but it's important to know that this is dimes and quarters. Thank you, Nature.
And then, what else is important?
Alright, so let's define our variables first. D is number of dimes. Q is number of quarters. $370 is going to be one of our totals. Anyone want to take a guess as to how we might set up that equation? And then we're actually missing information because it's information they assume you know already. Because if I just add up number of dimes and number of quarters, D and Q, I'm not going to get 370. I would need to, how would I add up to 370? Hannah. And add them together, yes. So 0.1 D plus 0.25 Q equals 370. Then for your other one, you have 5 more quarters than dimes. If you knew the number of dimes and added 5 to it, you would get quarters. Kind of think about it backwards. So this is going to be a Q equals. And even though this is set up very similarly to the last one where we could do substitution, we're going to do this by elimination. So which means we first have to make sure these are lined up. So we would subtract D to the side. And I'm going to rewrite this one below it. Because we have to find both number of dimes and quarters, it doesn't matter which one we eliminate first, because we'll have to go back and find the other. So do we want to eliminate dimes or quarters first? Okay. So that means we would need these to be the same. So we would have to multiply by 0.10. Or you can multiply by, bless you, negative 0.10 if you want to do the opposite operation. Doesn't matter. We have negative 0.10b plus 0.10q equals 0.5. To eliminate the d's, would we add or subtract? Add. They're opposite signs. So these would cancel. This would become 0.35q. This would become 4. And then divide. How many quarters do we have? And then we'll take that and put it back in to find d. Does not matter which one. So let's do q equals 5. 12 equals 5 plus d. Subtract 5. The number of dimes we have is what? If we were to put these, back into the equations, 7 plus 5 is 12, and then 0.10 times 12 plus 0.25 times 7, I'm sorry, I did that backwards, 0.10 times 7 plus 0.25 times 12 is 370. So that would work also. Questions on this? So we're going to start the maze that's on the next page, but we're not going to have time to finish today. So we'll get through 1 or 2 and then stop for today and finish the rest next class. So start at the start, read through that. Some of you are highlighting and underlining as you're reading. That's good. What is important here? Nature. What else, Lily? And what are we looking for? Cameron? So since we're only looking for one of the two things, we don't have to solve twice. So on your scrap sheet of paper, this is where we're going to do this work. So first we need two variables. Whatever variables you want, your favorite, doesn't matter. Give me two variables.
and y, it does not matter.
And F and T represent what?
So like,
What about them?
what don't we know?
Cost of, yeah. So cost of a fountain drink. And cost of popcorn. Then we need to set up two equations. We have 6 numbers in this. All 6 will be used in your two equations. The 220, 2250, and the 2375 are your totals. How would we set either of those up? Major? And the second one? Cameron? Now we have to choose which way of solving do we want to use. Graphing, substitution, elimination. Elimination, okay. Because we're looking for the cost of the fountain drink, if we get rid of P, we'll only have F left. So to make these the same, what could I multiply the top by? 2. And what would I multiply the bottom by? 3. So let's do that. We have 8F plus 6P equals, someone multiply that by 2, tell me what you get. And then 15F plus 6P equals, multiply that by 3, tell me what you get. And if we're eliminating P, would we add these or subtract them? We have negative 7F equals whatever that is. Subtract that. Tell me what you get. And then divide both sides by negative. What is that? 3.75, so $3.75. Be careful when you're solving. If you end up with a negative on one side, you should have a negative on the other. You should not end up with a negative number. Real world problems won't allow you to do that. So that means we're going to go this way. So go ahead and read this second one.
is important there?
Alex?
And it's important to note from where at the donut shop.
Anything else? Anything else? Teacher?
Both of those are totals, the 20 hours and the 196.
And what are we looking for? Lily.
So let's define our variables and then set up our equations.
So what do we want to call these two variables? Give me 2 letters, whatever you want.
So then x in this case would be
What? What don't we know here?
so we can say x is the number of hours worked in the bookstore. And y is the number of hours at the donut shop. So then we have to set up our equations. We know 20 and 196 are our two totals. This will be set up very similarly to the very first word problem we did. Anyone who wants to take a guess as to how we would do one of those equations? X plus y equals 20. And then the other one,
This should be the easier one because it gives you all the numbers.
how would we write that second one?
Nature.
But not right. It's like I heard you talking, but
You need to make sure that they went with everything. So the number for the donut needs to go with whatever we put for donut, the y.
so last problem we solved by elimination. So for this one, substitution or graphing? Substitution, okay. And then we are looking for how many hours we worked at the bookstore. So if we solve for y, we'll get an equation, put that in, and then the y's will disappear. So let's solve this one for y by getting rid of x. And then put that in for y in the second one.
all the y's now have disappeared. And just make sure we're on the right track. And y we said was on the top, so good. So now we can solve. What is 10.25 times 20? And we can solve for x. So if we subtract these two, what do we get? And then get rid of the 205 by subtracting. And divide both sides by negative 1.5. What is x? So then next class, the direction it starts off going 6. We will do that one by graphing, and I'll show you how to do that one in Desmos. But we'll stop there for today because we've done a lot.